So cute. Okay, 3-3, All right, we are going to continue derivatives, but today we're going to learn some derivative rules. Okay, and people, they forget these rules, and if you forget the rules, then you get the problem wrong. Now, there's two rules that we're going to learn today. We're going to learn the product rule and the quotient rule. Okay? So, the product rule for derivatives looks like this. Do you remember, like, the sum and difference rule was just to take the derivatives individually? That does not work for the product rule. So, if f of x is equal to a times b, and a and b are different functions, okay? They're not constants. Constants, you don't do this rule with it. Those are different functions, okay? A and b are functions. Then, to find the derivative of this function, it's not just going to be a derivative, b derivative, okay? You can't do that, a prime, b prime. Here's the product rule. Here's what you do. You do function a times b prime plus function b times a prime. Okay? That's really important that you know that. Really important. So let's do some. Number 1. Okay? Let's just do, like, some basic ones. So let's do f of x equals x squared plus 1 times x cubed plus 3. Now, there is another way to do this problem. You could FOIL the whole thing out and then take the derivative. Okay, and that would work great, and I'd probably do it that way. But right now I want to show you how the product rule works, okay? So this right here.
Nice one, Josh.
It's all right, Josh, you're okay. This right here is like a, and this over here is function b, okay? So what we want to do is we want to do a times b prime, okay? So here we go. Function a doesn't change. It's just x squared plus 1 times b prime. Well, what's the derivative of x cubed plus 3? 3x squared. Perfect. Plus, okay, so this is a, this is b prime, plus b, which is x cubed plus 3, times a prime, which is 2x. Perfect. Okay. So that's b, and that's a prime. There's a plus in the middle. All right, so now we need to clean this up. The rest of it's just algebra. Here we go. Distribute the 3x squared. You get 3x to the 4th plus 3x squared. Plus, over here, distribute the 2x. We get 2x to the 4th plus 6x. And now combine your like terms and write everything in standard form. So I get 5x to the 4th plus 3x squared plus 6x. And that's your answer. Okay? Yep, that's f prime.
The derivative.
That's the derivative, yeah. Okay? So let me show you if we would have taken f of x and FOILed it out. Okay, if you go back to the original, f of x is x squared plus 1 times x cubed plus 3. And FOIL that out. If you FOIL that out, you get x to the, what is that? X to the 5th. Okay. Wow, I just stopped. I was like, what is that? What happened? Plus 3x squared plus x cubed plus 3. Okay, if I were to FOIL that out and then take the derivative, it's actually an easier problem to do, right? You get 5x to the 4th. I'm going to go plus 3x squared over here, and then plus 6x. You get the exact same answer that you did here, but you did it a different way. Okay, so if I were given this problem and I was not told to use the product rule, I would FOIL it out, simplify my equation, and then do it. Now, why in the world would we need the product rule then if we can simplify it? Well, you can't simplify everything. We're going to get to things that look like this. Sine x times x cubed plus 1. Okay? You're going to have to use product rule there. Stuff like that. Okay? We're going to learn what the derivative of that is later. All right, you try one. You ready? Yay. Number 2. Try this one, if you will. Bless you. Oops, hold on. Let's do y equals 5x to the 4th plus 1 times 3x squared plus 2. All right? Find y prime using the product rule. Using the product rule. All right, I'm going to go ahead and start. You guys keep working. So it's going to be a times b prime, so leave the first one alone, times 6x plus b times a prime, b times 20x cubed.
Doesn't matter which one you have first.
Nope. And then go ahead and distribute, and you get what? 30x to the 5th plus 6x plus 60x to the 5th plus 40x cubed. Okay, did you get 90x to the 5th plus 40x cubed plus 6x? Yay. Okay, and then they could ask you maybe to take the second derivative of that, stuff like that. Okay? All right, so that's product rule. Everyone they do product rule pretty well. Quotient rule is the harder one. So here we go. Let's do part B. Quotient rule. Quotient rule. Okay, so now we have if f of x equals a over b. So we have a function over another function. Then f prime of x is going to equal, and the quotient rule is a little harder, okay? This is what the quotient rule is. It's ba prime minus ab prime over b squared. Pretty bad, huh? You know it's even worse is proving that. We're not going to.
So that's
Yeah.
pretty much the multiplication or whatever product rule over b squared.
It's product rule, but you have to make sure that you do ba prime first. Because minus matters, yeah.
Okay.
My dad taught it to me like this. He always said low d high, like derivative of the top, low d high minus high d low. Minus, oops, hold on, high d low. Low is b, the high is a. So he does low d high minus high d low over the square of what's below.
So it's b times the derivative of a.
Mm-hmm.
So it's not b times a, that's the derivative.
No, it's low. Yeah, it's b times a prime. So low d high, d means derivative. Low d high minus high d low. And then my nephew, who took calc in high school, he always said his teacher did low d high minus high d low, and did this whole row your boat. So, but always starts with low. And then my dad would be like low d high, he does this whole thing. It was pretty funny, but low d high minus high d low over the square of what's below. That's always helped me. I don't know. I hate memorizing stuff. I'm terrible at it.
Do you think your dad watches your videos?
No, I hope not. People in my first period, they watched my brother's videos, about the end of the world and stuff. And they said he hasn't posted in 2 weeks, so they're very worried about him. So Wyatt, I think, wrote to him today and was like, hey, man, you okay? You haven't posted in 2 weeks. All right, here we go. Let's do one. G of x equals x squared minus 1 over x squared plus 1. Okay, we're going to find the derivative of this, all right? This one would be terrible to do the limit as h goes to 0. I'm glad we have the quotient rule to use now. So we're going to find g prime of x. Here we go. So we're going to go low d high. So low is x squared plus 1. D high is the derivative of the top. What's the derivative of the top? 2x. Good. Low d high minus high d low. So high is x squared minus 1 times the derivative of the bottom, which is 2x, over the square of what's below. So you have to take the entire below and square it. Low d high minus high d low over the square of what's below. All right, and then we simplify. So take that 2x. Yeah, not at this point you can't because there's a minus here. So we don't have factors over factors. So we're going to distribute, and you get 2x cubed plus 2x. We're going to distribute over here and distribute the minus sign, okay? So I get a minus 2x cubed and a plus 2x.
Oh, no, that's not a minus.
Right. It's times right there, okay? Over x squared plus 1 squared. So our answer would be, to cancel those, 2x and 2x make 4x. And this would be our answer. And there's nothing else you can do, okay? That would be the derivative of that function. I could ask you something like, what would the slope of the tangent line be at x equals 3? And you'd have to plug in x equals 3. See, the derivative is still what is the slope of the tangent line. It's always going to be that.
You don't have to distribute the product?
Nope. Foil that out? No. Do not foil that. All right, let's do another one. Oh, let me show you this. Number 4. When you start doing these, and then people start thinking, okay, I have to do quotient rule for everything, that's not true, okay? If you have something like this, y equals x squared over 2, you don't need to do quotient rule here, okay? You can, you're just wasting your time. If you have a constant like that, right? You don't need to do quotient rule because this is the same thing as just 1/2 x squared. You don't need to do product rule there either. The only time you need to do quotient and product rule is if you have two separate functions that aren't constants, okay? So this one, you would just bring down the 2, right? Subtract 1 off. Your answer is just x for the derivative. Oop, hold on. I don't like how I wrote any of that because I didn't write y prime. Y prime would equal x. There's no quotient rule. There's no product rule there. Something like this, number 5. Let's say you have f of x equals x cubed plus 5 over x. Now, you can use quotient rule for this one if you want to. You can. Okay? But you can also try to simplify your function first before doing anything. And if you wanted to, you could simplify your function by doing this. X, what is x cubed over x? It's x squared. And what's 5 over x? It's 5 over x, okay? And then you look at that and you go, now I have to use quotient rule here, but you don't. Because this is the same thing as 5x to the what? -1. You don't have to use quotient rule at all. So if I take the derivative of this, I would go 2x minus 5x to the -2. Don't forget to subtract 1 off, which is 2x minus 5 over x squared. I didn't use quotient rule one time, not at all. Now, you could have started here, and you could have done quotient rule, and that would have been fine. You do low d high minus high d low over the square of what's below, and you would have worked your way, and you would have gotten this. But if you can simplify your function first, do that so that you can try to get around doing quotient rule. Okay, let's do a really tough one now. Are you ready for a hard one?
Sure.
Sure, let's wake you up. Here we go. Y equals 2x plus 1 times x squared plus 3 over x minus 1. And we're going to find the derivative. We're going to find y prime. Okay, there's no simplifying this one at all. Okay, you can't divide into these. This is just the way it is. There's no getting around it. We're actually going to do both quotient and product rule in this problem. Okay, so you got to think of this as the entire top is A, and then the entire bottom is B. Well, we're going to do the whole. We're going to do quotient rule, but when we get to taking the derivative of the top, we have to do product rule there.
Can't we just like take the derivative of the top first?
No, quotient rule is low d high minus high d low over.
Can we use product rule first and just multiply the top to get one thing?
No, what you can do, no, because you don't want just the derivative of the top, though. That's going to mess up things. What you can do is you can FOIL this out and make it a nicer problem. You want to do it that way? I kind of want to do it that way, yeah? Okay, so let's do that. Let's take the top and let's FOIL that out so that we don't have to do product rule. So we'll go 2x cubed plus 6x plus x squared plus 3 over x minus 1. Ooh, I like that better than worrying about like product rule up top. Okay, so now we have A, we have B. Let's go ahead and take the derivative. So we're going to do low d high, so x minus 1 times the derivative of the top. The derivative of the top would be 6x squared. I'm just going to rearrange this a little bit. Do you mind? And then plus 2x plus 6. Okay? So that's low d high minus high, which is 2x cubed plus x squared plus 6x plus 3 times the derivative of the bottom, which is 1. That's nice. All over x minus 1 squared. All right, so we did low d high minus high d low over the square of what's below. And then let's go ahead and, ew, really? We got to FOIL that out, super FOIL. X times 6x squared is 6x cubed. So I'm taking this and I'm going here, here, and there. X times 2x is 2x squared plus 6x. Now take the negative 1 and do the same thing. Distribute to all of those to get negative 6x squared minus 2x minus 6. The nice thing over here is that's just times 1, but everybody's going to get a minus. So minus 2x cubed minus x squared minus 6x minus 3 all over. And you never need to FOIL this out on the bottom. Just leave it as x minus 1 squared. Okay, do we have any like terms? I hope so. Yeah? 6x cubed and a negative 2x cubed? Okay. Oh, okay. So we have, what is that, 4x cubed. Now let's look at the x squares. I have 2x squared, negative 6x squared, and a negative x squared. Yeah? So how many is that? 2 minus 6, negative 4, one more, minus 5x squared. Okay, now our x's, I got 6x, negative 2x, and a negative 6x. That gives me negative 2x. I'm running out of colors. Blue. And then finally our constants, we have a negative 6 and a negative 3. That gives me minus 9. Ew. That is. Like, what did that just do? What did we just do? Well, we just found a formula.
Wasted 5 minutes.
No, we did not waste 5 minutes. That was
It wasn't
awesome.
hard. It was so extra.
It was very extra. Okay, last one, number 7. All right, so last one. It's going to be both. It's going to be both. Okay. So it says that, suppose that u and v are both functions. Okay? And they are differentiable. That means that you can take the derivative. They are differentiable at x equals 5. Okay? And then they tell us this. U of 5 is 4. U prime of 5 is negative 2. V of 5 is 1. And V prime of 5 is 7. Okay, here's what we're going to do. We don't know what the functions are. We don't care what the functions are. They're going to ask us to do, find the derivative of uv at x equals 5. Okay? That's going to be A. We're going to do a few of them. We want to find the derivative.
Is that just negative 2 times 7?
No, we have to do product rule. Yes. So we have to do product rule here. We want to find the derivative of uv first. So the derivative of uv would be u times v prime plus v times u prime. That's the product rule, right? ab prime plus ba prime. And at x equals 5, we would then get, what is u at 5? It's 4. What is v prime at 5? 7. Plus v at 5 is 1. And u prime at 5 is negative 2. So we would get 26 as our answer. It's just to kind of make sure you know how to do these. That's all it's doing. Let's do another one. How about d dx of u divided by v at x equals 5? U divided by v. Okay, u and v are both different functions, so we have to do quotient rule. Okay, so the derivative of u over v would be low d high minus high d low over low squared. And then you plug them all in. So what is v? This is at 5. We're taking the derivative at 5. So what is v at 5? It was 1. U prime at 5 is negative 2. Minus u at 5 is 4. V prime at 5 is 7. Over v squared, which would be 1 squared. So what do we get? We get negative 2 minus 28, so that would be negative 30. One more, last one. What if they did d dx of 2u minus 3v? Okay. This is at x equals 5 again. This is not product rule, it's not quotient rule, okay? It's a constant times u. So what would the derivative of 2u be? 2 times u prime. Yeah, that's it. Minus 3 times v prime. And so you plug... How come it's what?
The derivative. Why are you using prime instead of regular?
Oh, I always use prime. Yeah, so you could use like y prime is the derivative, f prime of x.
No, why are you using u prime and not u?
You don't need to. If you're taking the derivative of u, it's u prime. And if there's a 2 out front, you just multiply it by 2. It's kind of like if you had y equals 2x squared. You take the derivative of that, multiply it by 2. So it's just 2u. All right, so it's 2 times u prime. What was u prime again? Negative 2. Minus 3 times v prime, which is 7. So negative 4 minus 21, negative 25. Phasers. Some books like to do dy dx a lot. That's the derivative of y with respect to x. It's the same thing as just y prime when you have a function of x, which is the same thing as f prime of x. They're all the same. I just like writing prime. I think that's Newton and that's Leibniz, one or the other.